Right, welcome to Unit 7. This is all about similarity. In 7.1, we are going to start with ratios and proportions. So, go ahead and answer the following questions about a ratio. Alright, so first of all, explain what a ratio is. A ratio is just simply a relationship between two numbers. So, a relationship between two numbers. So question B is going to be very hard for you to answer without being in my classroom. But what is the ratio of lights on the ceiling to calculator storage pockets? Write the ratio 3 different ways. And the correct answer to this one, which once again you guys don't know, is 16/20. And we can write it as a fraction. But anytime we do a ratio, just like a fraction, we want to make sure that we reduce it. So we would say that the ratio of lights to calculator storage pockets would be 4 to 5. And we can write this 3 different ways. So the first way is like a fraction. We can write it with a colon. So 4 to 5 that way. Or we can just write it with the word 2. 4 to 5. All right, so what is the ratio of students that ran a mile in the last 5 minutes to all the students in the classroom? Well, assuming there are some students in the classroom, and assuming that, man, these questions are tough when we're in COVID times here. So what is the ratio of students that ran a mile? Typically, I have 0 students that ran a mile, and about 30 that are in the classroom. So it's okay to have a ratio that's 0. And what's the ratio of students in geometry class right now to all the students in the classroom? Well, if you're on Zoom and if you're in the classroom, then this is going to be 30 out of 30. So it's once again okay to have a ratio that is equal to 1 as well. And in fact, we would say that this is a 1-to-1 ratio. All right, we can also use ratio to express slope of a line. So slope is just a fraction that compares, has a relationship between two numbers, right? It has a relationship between the rise and the run. So if I zoom in a little bit on this picture, we can get a little little bit more accurate. And we can say that we have, let's start with line L. All right, we've got this point and we've got this point. So my rise and my run is up 3/2. So 3/2. I can find my slope of m. Right, I go down 1/4. And then I can find n as well. And for that, I go down 5/2. So you guys have used ratios a lot. You might just not have heard the term or not been knowing that you've been doing them. But doing slope is a way of using ratios. All right, if we look at question 3 here, XYZ is a triangle with side lengths in the ratio 2, 3, and 4. The perimeter of XYZ is 27 yards. Find the length of the shortest side. Okay, so this question, along with number 4, are going to be 2 that you are definitely going to want to make sure that you know how to do these. They'll show up on the test, but they also show up a lot on standardized tests. So the good part about these is they're not too difficult, right? So to find perimeter, we just want to add up all the sides. But the problem here is that we don't know exactly what the sides are, right? Like obviously the sides aren't 2, 3, and 4 because that does not add up to 27. But we do know that they're in some proportion or some ratio of 2, 3, and 4. So therefore, I know that I have a side that is 2x, 3x, and 4x. Right? They're in some sort of proportion like that. So then I can find the perimeter, or use the perimeter, to find out what that x is going to be. Right? So we add up all sides and set that equal to our perimeter. 2x plus 3x plus 4x is 9x. And then I can divide by 9 to get x equals 3. So now I know that the sides are going to be 6 by plugging in x. I know that this side is going to be 9. And I know that that side is going to be 12. And when I add 6 plus 9 plus 12, I do get 27, so I know that's correct. So let's make sure we answer the question. The shortest side is going to be 6 yards. We got a label based on that word right there. So, cool. You may also get another question that is very similar based on angle measurements. And the reason this is such a popular question is it's based on everything we did, or a lesson in Unit 6. So the ratio of angle measurements in a quadrilateral is 1 to 4 to 5 to 6. We want to find each angle measure. So we've got some sort of quadrilateral here. Let me make it less perfect. Here we go. Something like that. And once again, it doesn't matter if my drawing is accurate at all. And actually, I'm going to draw more like this. Here I say it doesn't matter if our drawing is accurate, and I go and change it a bunch of times. Okay, so remember, we don't know exactly what we've got going on here, but we've got one of our angles at a proportion of 1x, another angle at 4x, 5x, and 6x. But the nice thing is that if it's a quadrilateral, we know what it adds up to, right? If you don't remember, we can always do 180 times n minus 2, which is going to be 180 times 4 minus 2, since it has 4 sides. 180 times 2, and we get 360. So I know that I can add up the proportion to be 1x plus 4x plus 5x plus 6x is equal to 360. I then can combine like terms to get 5 plus 5 is 10 plus 6 is 16. So 16x equals 360. And then divide by 16 to get 22.5. So once again, make sure we answer the question. It does say find each angle measurement, so I do have to plug this in. So I'm going to get a 22.5 degree angle with the 1x. And then if I take 22.5 and I multiply it by 4, I get a 90 degree angle. And then if I take the 22.5 and multiply by 5, we get 112.5. And last but not least, when I take that 22.5 and multiply it by 6, we get 135 degrees. So those are my 4 angle measurements of the quadrilateral. And I can add those up, and when I do get 360 as a check. So once again, those two questions, question 3 and question 4, are definitely ones you're going to see throughout the next couple of years. So make sure that you kind of understand those and feel good about those. Then we're going to do a little bit of work with proportions here. So we want to answer the following questions about a proportion. Explain what a proportion is. So a proportion is going to compare two ratios, so typically of unrelated items. And when I say typically of unrelated items, is when we start talking about more of the geometry definition of it. So I can set up a proportion that's going to compare the big side of a triangle to the small sides of a triangle, or something like that. So when we set up proportions, which we're going to do a lot, we want to make sure that we're kind of setting them up as two ratios and that they are of unrelated items, and we want to figure out what those items are to help us set up a correct proportion. All right, part B, in a proportion, if A over B equals C over D, then why can B and D not be 0? And this is simply because we can not divide by 0. All right, so we can't have the denominator of our fraction being 0, otherwise it won't work. I'm going to skip parts C, D, and E there. You can take a look at them if you want on the notes. All right, so let's start with number 6 here. We want to use algebra to solve the following proportions. And to do this, we're going to do Most people probably call it cross multiplication. I typically call it diagonal multiplication, just to keep it easy. So first thing is that we're going to carry our equal sign down, so that's important. And then we're going to multiply diagonally. So 6 times x is equal to 9 times 10. So we're going to multiply both of those. So 6 times x is obviously 6x, and 9 times 10 is going to be 90. And then we can just treat this as a normal problem. I would divide by 6 on both sides, and we get x is equal to 15. All right, go ahead and try B on your own. Pause the video and come back and see if you got the right answer. I will give you a hint, you will get a decimal. All right, so we get 4.2 for that answer. All right, and for C, when we talk about order of operations here, we actually have an understood invisible parentheses around everything. So that when I do the cross multiplication here, I'm going to get the 10. I'm going to multiply it by b plus 5, which is kind of in parentheses, which means that we are going to end up distributing that. So I can do 10 times b and 10 times 5 here to get 10b plus 50 is equal to 35. So it's super important there that we do multiply the 10 by both the b and the 5. A very common mistake is only to do, we get 10b plus 5. So you want to make sure that you get actually 10b plus 50 to be your answer here. And then I can just solve it like a normal equation, subtract 50 from both sides, and I get a negative 15. And then divide by 10, we get negative 1.5 as our answer for B. All right, go ahead and give D a shot. Okay, it's pretty similar to C. Pause the video. When you come back, you will see the answer. All right, so don't forget to distribute the 9 to the R and the negative 3, and then you'll get an answer of 5.66 repeating, or 5.67 if you rounded it. All right, question E, once again a little bit trickier. But if we follow our steps, we'll be okay. So we have 6 times k minus 7 is going to equal 9 times k. When I distribute that, I get 6k minus 42 is equal to 9k. I can then subtract the 6k over. Negative 42 is equal to 3k. And then I can divide by 3 on both sides to get k is equal to negative 14. All right, and this last one is by far the trickiest, but all something that you should be able to do and can solve, hopefully. So we are going to set it up. So we would have u plus 3 times u minus 3 is equal to 8 times 5. And once we have that, we can then do what we call FOIL, or double distributing. Your algebra teacher last year might have used either of those terminologies. But essentially what we're doing is we're just distributing. So the first thing I want to do is I want to cover up the 3 and distribute the u to both sides. Okay. Then when I get done with that, I want to cover up the u and distribute the 3 to both of those. So that's why we call it double distributing, because we're distributing both parts. So let's do it. So first the u is going to distribute to both of those. So u times u is u squared. And if you're starting to see a u squared, that should scare you just a little bit, but let's continue the problem. U times a negative 3 is going to be a negative 3u. Okay, now you should be very scared that we have a u squared and a normal u. But let's do the rest of it. So 3 times u is going to be 3u, and 3 times a negative 3 is a negative 9. And that's going to equal 8 times 5, which is 40. All right, so at this point, you should be scared. But fear not, negative 3u and positive 3u are going to actually cancel themselves out. So I'm actually just left with u squared minus 9 equals 40. All right, so then we add 9 to both sides, get u squared is equal to 49, and then I can square root both sides. And remember, if you have a u squared, you're going to get 2 answers, so I'm going to get u is equal to plus or minus 7. And there is my answer for that. And I can plug a positive 7 and a negative 7 in, and they both work. They both are correct. So that is 7.1, and that's solving sum proportions.